There's a big crowd. Oh, because of all the craziness with the Great Hall or whatever? Okay, guys. Hopefully you have your notebooks out. Hopefully you have your notebooks out, computers are closed and put away. No, I'm not like randomly listening to music. I'm trying to record this. I'm trying to sync up my audio, just as a heads up. If you see an AirPod in, you're like, what's she doing? I'm trying to record this lecture today, so we'll see how it goes. Today we're going to talk about something called the power rule. Okay, we're going to talk about something called the power rule. The power rule is one way that we can use to take derivatives. So we've talked about derivatives so far. The only method we know right now to take a derivative is using f of x plus h minus f of x over h with the limit as h goes to 0. Or the other definition that we talked about is f prime of a with f of x minus f of a over x minus a. Okay, just a quick refresher. What is a derivative? Yeah. I would not say any line at a specific point. Yes. A tangent line. Okay, so we could have a line that like intersects somewhere else, like a secant line. We want the tangent line at any point. So it's the slope at any point on a curve, okay, or on any graph that we have. The power rule is a rule that works to find derivatives, and it's much faster in general than using the definition of the derivative. But it has a lot of limitations. It only works for power functions. So a power function, as an example, is something like a polynomial. That would be a power function, okay? A power function means something that you can write as the addition and subtraction of terms that are raised to a numerical power, okay? So like x squared or x to the 1/2 can be a power function, or x to the -3 can be a power function, okay? Something like 1 over x plus 3 is not a power function. And you cannot use power rule. Power rule will not work. That is a rational function that we cannot write as a power function. Some of you might say, well, yeah, this is the same as x plus 3 to the -1, which is true. That is still not a power function. You need the addition and subtraction of individual terms raised to a power. You cannot distribute that -1. That's not how that works. Okay? Similarly, things like trig, sine, cosine, tangent, not a power function. Things like log, not a power function. Things like e to the x, not a power function. So it only works for very specific things, and it must be written as a power function in order for power rule to work. But it's great if you have a power function because it's really fast. Okay, so an example of a power function, please write this down, is a times x raised to the n. A times x raised to the n. Okay, and then, like I said, there could be plus or minus additional terms there. This is just one example. F prime of x, which is the derivative of that, is going to be equal to n times a times x to the n minus 1. Which means what you're doing is you're taking that power, you are multiplying it by the coefficient. Okay, you're leaving x like it is, and then you're subtracting 1, the number 1, from whatever your power was. Okay, does that make sense? You can look back at your notes. It's pretty cool. Make sure for the homework, the quest, the 2.1 quest, you are using definition of the derivative. That entire quest is meant to be done with the definition of the derivative, or what some guys call the long way. You do need to do that. I promise I wouldn't waste any class time on something that you didn't need to know for the test. So 2.1, you need to use the definition of the derivative. The other quest, I think it's 2.2, I forget what the number is, but the second quest that's due this week, you can use any method that we discussed, okay? All right, let's do an example. F of x equals 2x cubed minus 4x squared plus 8x minus 11. We're going to do this one together. If you are super good at the power rule, please do not skip ahead, because I really want to make sure we're discussing these together. Okay, so go ahead and write down A. F of x equals 2x cubed minus 4x squared plus 8x minus 11. Okay, the derivative of this is going to be the derivative of each piece because they are separated by addition and subtraction. So I'm just going to apply the power rule to each piece of this function because each of those is a power function. So the first thing I'm going to do is 3 times 2. Okay, so 3 times 2 is 6. X raised to the 3 minus 1 would give me a squared. That's the derivative of the first one. I didn't have to do x plus h cubed, right? So already we're saving a ton of time. The next part is minus 4x squared. So I'm going to take the 2 down. It gets multiplied by the minus 4. So that gets me a minus 8x. Now 2 minus 1 is just 1. So that's raised to the first power. You can write to the first power if that helps you keep track, especially when you're starting. You do not have to write to the first power because something raised to the 1 is just that something. Okay, I have it there just so we're clear on how that worked. The next one is plus 8x. This power currently is 1. Right? So as you're doing this, sometimes it's helpful to write those in so that you know what you're multiplying. We're multiplying a 1 times an 8, so that's plus 8. And then we would have x raised to what power? 0. Okay, we'll come back to this in a second. Then I have just the number minus 11. As I said, everything has to be a power function. Is minus 11 a power function? It doesn't look like it, but I can write it as a power function because secretly, any constant, any just number by itself, is x raised to the 0 power. Okay, so a constant is really negative 11x raised to the 0 power. The derivative of that constant works exactly the same way as the other power functions that we've done so far. So the first thing I do is take my 0 and I multiply it by the negative 11. So that's plus 0 x to the negative 1. Let's talk through the last 2 pieces. Okay, the first 3, or the first 2 are going to stay the same. 6x squared minus 8x. Like I said, you don't have to write to the first power. 8x to the 0 is the same as just plus 8, right? And then what's 0 over x, which is what 0 times x to the negative 1 is? What's 0 over x? 0. Okay, so I get a value of 0 there, which means this would be my final answer for my derivative of my function. Yes. Will every constant be 0? That's a good question. So if I have a constant, let's say my graph was just that minus 11. Let's say I had f of x equals minus 11. What does that look like on a graph if f of x was just minus 11 everywhere? No matter what my x value is, close. No matter what my x value is, it's always negative 11. What does the derivative find? The slope, right? The slope of the tangent line. What's the slope anywhere on this graph? 0. So yes, the derivative of any constant will be 0 because the slope of any constant is 0. That makes sense to everyone. Okay, fantastic. Do the next one with your partner, B. Please do not work ahead. I've already said that once. Please take me seriously. Work on B with your partner. Go. Yes, and I should have written that. Thank you. My labeling is incorrect. Thank you, thank you, thank you, thank you. Make sure you do not have this incorrect in your notes. This should be f prime of x equals. I apologize for missing that. F prime of x equals. Thank you, thank you. Okay. All right, with your partner, B. You're covering because you've already done it. Scratch it out and start over. With your partner, Gray. With your partner. Make sure you write it down correctly. That does impact things. All right. So f of x was 10x to the 13th plus 4x to the 11th minus 17x squared plus 9. Derivative of 10x to the 13th. You definitely do not want to do that with definition of the derivative, right? You do not want to figure out x plus h times x plus h 13 times. That would be a long process. You could, you'll get to the same answer, but you'll have like a whole notebook of work. So 10 times 13 is what we're doing first, which is 130x to what power? The 12th plus, what would be next? Good. Next. Minus, do not drop those negatives, minus 34x plus 0. And you can write plus 0 or you can leave it off. That's fine either way. Okay? Now, power rule, super easy, right? Guess what? They are almost never going to give you something like this. Those are such easy functions to use power rule on. So if you're like, oh, I got power rule, I totally know all of calculus. You know, like 1 second of a year class. Okay? If I give you something like this is not a power function. This is a radical function. But I can rewrite it as a power function if I want to use power rule. Again, I apologize. Make sure you're labeling this right. I don't know why I'm failing today. We are finding f prime of x for all of these. So this function can be written as a power function. This is the same as 5 times x raised to what power? Yes, 7/3. That's correct. Okay, common mistake, students will change that, and then they'll think that that is the answer. You still have to take the derivative of this thing. With your partner, do this one. Go.
So then 7/3.
Don't forget to multiply by the 5. 7/3 gets multiplied by 5.
Oh, I did that wrong. Yeah, I did.
Okay. So we have 5x to the 7/3. We're going to do 7/3 times 5. Remember, that power gets multiplied by that coefficient. 7 times 5 is 35 over 3. Then we have x raised to. Easiest way to think about this is minus 1 using whatever denominator you have. So minus 3 over 3 is how I would think about it in my head. Minus 3 over 3 gives me a positive 4/3. Okay, sometimes on College Board, you'll have to put this back into radical form. Just depends on the question. If I don't ask for it, you can leave it here. Just be aware of how to do that. Any questions on that one? Okay, G. A lot of students will make a very silly mistake on how to rewrite this. This also not a power function, but you can rewrite this as a power function. Be careful setting this up. I'm going to give you about 30 seconds to rewrite it and solve. Go. Okay. This is the same as 1/9 times x to the negative 1. It is not the same as 9x to the negative 1, which is the common mistake I see. It is still being 1/9. You are doing 1/9 divided by x. You can also not write this as 9x parentheses to the negative 1 because that is not a power function, actually. Weirdly enough, that is not a power function. Okay, you can't have parentheses of something raised to a power. You cannot have parentheses of something raised to a power. It is not a power function. Okay, so we have 1/9 x to the negative 1. This one should be simple, but again, a lot of students make mistakes. There's another reason a lot of students make mistakes, and that's because we are bad at subtracting. We are bad at subtracting 1. Okay, what I will commonly see is that students will think that negative 1 minus 1 somehow equals 0. It does not. I'm going to take that negative 1, multiply it by my 1/9. I'm going to have negative 1/9. Don't forget to do that. And then I'm going to have x raised to what power? Negative 2. Common mistake is to think that it is raised to the 0 power. That would be adding 1, not subtracting. If you have a negative number and you subtract 1, it gets more negative. Okay, questions on that? Yes. Negative 1 over 9x squared? Absolutely. Totally. It is equal to that. What my recommendation is, if they don't ask you to rewrite it, just stop here. Because if you make a mistake between this step and this step, now you don't get credit. Okay? If they ask for this, then yes, obviously you need to get there, but don't simplify if they don't ask you to. Okay? Great question. All right. C is not a power function. What? C, Toshner. Oh my God. Need to stop making up problems right before class. I'll fix these. E is what you're going to be working on, and I'll change those in a second. Not a power function for several reasons. One, there's a radical. Two, there's parentheses and multiplication. Okay? But you can make this into a power function. With your partner, make it into a power function. Then please find f prime of x. Go. You're a genius. Good job. I'm just repeating what he said. I didn't check anything you did. Okay, quick review. Quick review. X squared times x cubed equals what? X to the fifth. What did you do with those numbers? You added them. Okay? Square root of x is the same as x to the what? 1/2. I'm distributing that to both of those things. So I'm multiplying by x squared minus x to the 1/2 times 5 times x. You can write that a multitude of different ways. Here's how I'm choosing to write it. Maybe put this minus 5 in the front. That's fine if you want to do it that way. Okay? You are adding these, not multiplying them. Be careful of that. You are adding them. So choose a common denominator. That's the easiest way to add. Squared, the denominator would be 2. So times 2 over 2 is 4/2, right? X by itself is x to the 1, so 2 over 2. Okay? We add these together, I would get x to the 5/2 minus 5x to the what? 3/2. I have still not even taken the derivative yet. All we've done is create a power function out of this. Just a clarification. If you took the power rule and used it to this part and then separately used it to those parts, you would not get the right answer. That is not how power rule works. Okay, so you cannot do it that way. You have to create a power function and then use power rule. Giving you another 30 seconds to figure out what that derivative is. Go. Remember, subtracting 1 is the same as subtracting 2 over 2. Yes, sir.
Same thing as limit squared. Every line of work that I'm showing you to put f prime of x.
No, if you have equals, this is telling me that this is all equal to this. The reason we needed it for a limit, because a limit is not like an equal sign, it's like an operation. So if you were doing like 2 times something and 2 times something, you have to show the 2 times every single time until you actually do it. All right. I think that was more than 30 seconds. We get 5/2 x to the 3/2 minus 15/2 x to the 1/2. Again, yes, you could put it back in radical form. Sometimes you will have to. If I don't ask you to do that, just leave it here. Okay? Are there any questions on this? Also, do not randomly change that to 2.5 because why would you do that? Just leave it as a fraction. Okay? Erase. You love decimals. I don't know why. You'll like fractions more after this class, I promise. Okay, F, with your partner, go. If you're stuck or have a question as we're going through these, I am walking around. Please ask so I can help. It will continue to get more challenging, and make sure you are comfortable with this. A lot of really good discussions happening around this. A lot of very good discussion. Are you raising your hand? What did you say? Say it again. Didn't you just say, oh, someone behind you did. Okay, sorry, you were talking and then I just heard a response. So someone said a thing that does matter a lot. Okay, if I have not already told you, College Board, there is just a bunch of trolls. It's a bunch of people who are sitting in a room trying to trick high school students. That is what I am convinced that College Board is. Okay? They love questions like this. They love a question like this because even if you know power rule, when you're stressed and in the situation of test taking, we're going to do things that seem like they make sense. It seems like it's proper calculus, but it's not. Okay? Let's start here. 6 over 5x squared. First, I need to rewrite that as 6/5 x to the what? Minus 2. Okay? Make sure that you know how to write that correctly, that you're not also bringing the 5 up. That is a common mistake. Okay? And then we have minus 4 pi cubed plus e squared x. The first one, when I take the derivative, again, label that appropriately. It's not too bad. We're taking negative 2 multiplied by 6 over 5. That's negative 12 over 5. Again, be cautious to actually subtract 1. Minus 2 minus 1 is minus 3, not minus 1. Okay? Sometimes we go down in magnitude of number instead of actually becoming more negative. That's our common mistake there. Okay, the second two are the trolley bits of this. So I have minus 4 pi cubed. Very, very common mistake I see from students is to write minus 12 pi squared. Because it seems like that's doing power rule, bringing the 3 down, and we're subtracting by 1. So why is that not minus 12 pi squared? Yes. Pi is not a variable. What's pi? A number. It's around 3, right? Which means this is also just a number, right? It's like having minus 100 there. Minus 100 is, again, just a horizontal line with the slope of minus 100, 0. Okay? That's a constant. Derivative of a constant is 0. Okay, that part goes away. Similar mistakes will happen on this second part. We have e squared x. We see a power, so often we want to bring it down as 2 times e times x. What's wrong with that? E is also a number. E is also a number around 3. It's 2.7. Okay? That number happens to be squared, and they happen to leave it that way, e squared. But it really just means a number like about 9. If I had 9x, the x is still raised to the first power, right? So I care about the x being raised to the first power. I would have 1 times the e squared times x to the 0, which would give me just what? Just e squared. Okay? Yes, absolutely. E squared x. The x is the only power I care about. E squared is just a number. So it's like having 9x, for example, about, right? 2.7 squared be about 9. So when I do the derivative of this, I'm really just doing 1 times e squared times x to the 0. The only thing that's changing is the power of x. not the power of constants. Good? Questions on that? All right, G, not a power function. You can make it into one. Just a heads up, as I said, you cannot make every function into a power function. Okay, but these ones that I've selected, you can, so that we can practice power rule. Okay, with your partner, go. Questions?
With this, I cannot put this in parentheses by keeping this out, or
You can't have parentheses for power functions.
so it's just so even if it's just x minus 2 inside the parentheses, it won't work.
Yeah, nothing inside of parentheses will work. I haven't taken a derivative yet. I'm just writing a step to help me simplify this. Remember, if I am dividing an entire numerator by one term, each of those things in my numerator gets divided by that term. So I'm going to have x cubed divided by this minus 2x also divided by this. You have to use it for every single thing up there. Okay? Now, just like we did x squared times x cubed equals x to the fifth, if I did x to the fifth divided by x cubed, hopefully you know we get x squared. You're doing subtraction if there's division. Okay, so I'm doing subtraction. Again, I think it's very, very helpful to change my powers so we don't make silly mistakes. So 3, if I want it to have a fraction denominator of 2, is the same as 6 halves. X to the first is 2 halves. It takes 1 second to do that. I promise it will save you some silly mistakes. Okay? So I still have a 5 in the denominator. One way that you can write that to make that easier to think about is probably just pulling it out in front as a 1/5. I recommend that. You don't have to. It's fine to leave it as over 5, but calling it 1/5 times sometimes makes things easier. So we have 1/5 times x to the 5 halves, because we're subtracting 6 halves minus 1 half. And then I have minus 2/5 times x to the 1 half. I still have not taken the derivative. Okay, so we need to take the derivative from here. That would be f prime of x. What do we get for f prime of x? So 5 halves times 1/5 is just what? 1 half x to the 3 halves minus 1/5 x to the negative 1 half. Be careful sometimes with fractions and subtraction, we are even worse. Okay? Negative fractions and subtractions, oh my God, hold on to your butts. Okay? Any questions on this one? Buenísimo, questions? True. So yes, you get 5/10, or what's easier in general to think about is just canceling out the 5/5 right away. Okay? Excellent. H, not a power function. You can make it one. I would recommend foiling the x minus 2x plus 1 first. That would be my suggestion. You do you. But I would multiply these first and then multiply the negative 3x squared and then take the derivative. Go. Yeah. Yes.
It's like negative 12.
Please check in with your partners. Please work on these together. It got a little quiet. Do want to make sure all of you are working together. Okay, remember when we are multiplying x squared by x squared, we are adding, we get negative 3x to the fourth plus 3x cubed plus 6x squared. Be careful of addition and subtraction. Negative times a negative is a positive. Our f prime of x should equal negative 12x cubed plus 9x squared plus 12x. Is this what you guys got? Fantastic. Questions on power rule so far? Okay, Ms. Tasha, now that I know power rule, do I ever have to use definition of the derivative? Absolutely. I promise I would not have wasted multiple class periods on that if you did not need to know it. It's all over the test. It's sometimes on true response. Yes, you need to know how to do it, which is why I taught it to you first. Yes, sir. If they do not specify the method, then you can use whichever method you choose. And so if they don't specify and it's a power function, you definitely should use power rule. You should not be using definition of the derivative unless they tell you to. But they will have stuff on there. And very commonly, there's some of those questions that's like, what does this thing find? Or you don't even have to use, like, you're not multiplying out definition of the derivative. You just have to recognize it. That's very, very common. Yes. Say what? Anything that's not a power function. For example, sine or cosine or ln or e to the x or square root of 5x minus 1 or parentheses 10x minus 3 to the 99. Doesn't work. Good. Lots and lots and lots. I gave you, it looks like a lot of different kinds of questions, but I knew these could quickly be used in power rules. We will talk about a lot of different kinds of rules we can use later. Good? There are several. Okay, now we're going to do an actual practice problem where we're evaluating. So this question, evaluate f prime of negative 1 given f of x equals, means we're trying to find the slope of the tangent line at negative 1. That's what we're looking for. So before we can do that, we need to find f prime of x. We need to find f prime of x first, and then to evaluate f prime of negative 1, all you're doing is plugging negative 1 into your derivative. Okay, please do this with your partner. I know you can do this by yourself. I want you to talk through it together. Go. Yeah. You have to find the derivative first, and then you can evaluate it at negative 1. So just how we found f prime of x for all of these, you're finding f prime of x. Then we're going to go a step further by plugging in negative 1 into whatever our derivative is.
Wait, no. Yep. Is it negative?
Negative 1. Look at all those negatives in that question. Love it. I love it. I love it. I love it.
Have like a full year to
I think so. I feel like they take like the meanest problems that they all come up with separately and put them into a test. Luckily, I know the test very well, so I know what they do that's mean, and we talk about it a lot. Okay, guys, let's go through this. I do have a lot I want to get through, so let's try to stay on track. If you and your partner are done, let's try to keep the conversation on this. Okay. What I said earlier was we should always rewrite it as a power function first. Some of you will skip this step and make silly mistakes. So you'll notice the very end, we had 11 over x. I rewrote that as 11x to the negative 1 before doing anything else. I have labeled this as f of x. I have labeled this as f prime of x. Okay? Again, be careful. I heard several of you make this mistake as I was walking around. Negative 1 minus 1 is negative 2. It is not 0. So be cautious of that. Okay? What I said earlier was we don't need to rewrite this, but sometimes if you're evaluating, it's helpful to do that. It is helpful to see it as minus 11 over x squared. Sometimes seeing it that way and plugging it in that way just gets us there to that correct answer a little bit easier. So we don't accidentally think we're like raising it to a negative 1/2 or a positive 1/2 or something else. Okay. Negative 1 squared is 1. 1 times negative 6 is negative 6. 10 times negative 1 is negative 10. Minus 9, and then minus 11 over negative 1 squared is over positive 1, so minus 11. So we have negative 6 minus 10 minus 9 minus 11. Look at all those fun negatives. Minus 9 and minus 11 is minus 20. Minus 6 and minus 10 is negative 16. So you get minus 36. Anybody get that right? Wowzers. Nice job. Okay. Listen to this question. Listen to this question carefully. Is f of x increasing or decreasing when x equals negative 1 and y? Someone raise your hand. Yes. Okay, so it and it is not going to be a sufficient answer. Try again. Yeah. It, what's increasing? What's it? Okay, sorry. I interrupted you right when you said it. You're so close. You got the first part. F of x is increasing when x equals negative 1 because, take off from there. Is take off one word from that. It doesn't matter that it's specifically negative 36. What does it matter? That it's negative. Okay, it matters that it's negative. So I will roast you guys when we do a lot of it's or the function or whatever. I want to make sure we can clarify to get f of x is decreasing when x equals negative 1. Okay, that's answering the question because f prime of negative 1 is negative. So the fact that our derivative is negative at x equals negative 1 is why our original function is decreasing, and we can know that for sure. Okay, excellent job. Most of you knew the answer to that. It's hard to express, so that's why I'm working on that. Next problem. Find g prime of 4 given this thing. Make sure you rewrite it as the power function first. Go. What? What's it supposed to be? But I asked you to find g prime of 4. I think I wrote this right. Gotcha. 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 That would have been so much easier. Actually, make sure I could have given that to you. If that was what I did, by the way, sorry. Yes, that was a mistake. If there was a g prime here, how would you evaluate g prime of 4? What would you do? Yeah. You would just plug it in. So yes, great job for anybody who caught that. Your reading skills are excellent. Okay, but no, I do actually want to practice taking a derivative.
I think I understand this a lot better than
Excellent. This is not bad. This is pretty easy stuff. This is good. Because they're subtracting 1 from negative 1/2. This was in the denominator, so that's a negative 1/2. Subtracting 1 is negative 3/2. 12 over 10, 2. I made this one up. It's probably weird. I made this one up right before class, so it's probably a weird answer. Oh my God, what kind of a problem is this, Miss Toshner? I'll probably change this for the other class. Oh my God. I have no interest in continuing to simplify this, to be honest with you. Great. Okay, great. Okay, where are you confused?
So it's
Blue. Are we good with blue? Purple. So 3/2 times 4/5. So 2 times 3 is 6, and then a 5.
6 bits to the
Agreed. This is what happens when Miss Toshner just makes up problems right before class. They don't turn out always so nice. Nah. No. Just the fractions are weird here. The fact that there are these radicals in the denominator or whatever, that's pretty common. There's one kind of like this on your quest, but the numbers are a little bit nicer. Just a heads up. Here's what's super important that we really get to. Understanding that this, first of all, getting this answer, which is our derivative, f prime of x, and then getting to simplify it to this so that we know how to put radicals in. So x to the negative 3/2 means that the x thing is in the denominator, because it's negative. The minus 3/2 means in the denominator, I have a square root function that's cubed. One mistake I have up here, so I did this while I was working and I need to correct it now. Make sure your notes are correct also. This is g of x. That's how we rewrote it as a power function. This is g prime of x. Where is my mistake? Does anybody see it? Yeah. So I don't need g prime of x again because I have an equal sign. So this clarifies that, hey, that's also this and that's also this. Yeah. I need g prime of 4. So I need to clarify once I plug in a value that that's no longer g prime of x. In general, it's specifically g prime of 4. Also, I picked up my green marker to give you a hint. Yes. Yes. Do you have a question? Okay, look at it for a second. Ask again if you have it. Yeah. That's right. That's correct. That's correct. Yep, exactly right. Well, okay. Question 3 is one I get a lot of questions about. Like, what's it asking? I would like you and your partner to read this carefully, make a plan, and go. The last one broke you?
I don't want to do that. No, never mind.
Let's just do math with your answer to how to do this. Okay, cool. All right, well, because we're literally doing power rule today, you might have guessed that that might be part of the process here. Just a heads up, the College Board is not like, hey, we're in the power rule section of the test. Here's where you need to use this. This question could come up anywhere in any portion of the exam, and you'd have to know how to approach it. So it says find the x coordinates or coordinates. There might be more than one, where f of x has a horizontal tangent line. So I have some cubic function. We're looking for where we have horizontal tangent lines. Okay, factoring this is not going to help us, nor can we factor this. I'm looking for horizontal tangent lines, which means I need the tangent line slope. Another word for tangent line slope is what? Derivative. I need the derivative to be equal to 0. Some of you think I'll find the derivative and then plug in 0. That's not finding where the slope is 0. That's finding what is the slope. Excuse me? I thought we had a lot more time. Okay, have a great weekend. You have homework that'll be on this. So set the derivative equal to 0. I do not know why I thought I had 10 more minutes, but that's fun. Yep. It's all the same stuff. Guys, just real quick. This just means find the derivative. Just a different way to write it. It just means find the derivative. Yeah. Yeah, take out a 6 from everything, and then FOIL.
All right, sweet, thank you.
Or factor, not FOIL. I don't remember. Well, we'll be going over what? In a while. You can look on the calendar, but it's in a little while.
I jumped to physics C.
Uh-huh. We'll get to it in like a couple weeks, maybe a month or something. It's soon. Yeah, we will cover all content by Thanksgiving, I think. So just hold on tight. Brutal, brutal. Yeah. I don't know. -2 and -4, is that what you're saying? Are you giving me an X and a Y pair? Oh, I don't know. It might be. I don't remember. 6x squared minus 6x minus 72 equals 0. 6 x squared minus x minus 12. X minus 4. X plus 3. X equals -4 and x equals 3. Yes. Okay. How was your birthday? Did you do anything fun? Good. How old are you? Woo! Did you get your license? All right, when are you getting it? Oh no. Oh, because you got your permit late or something? That's a bummer.